Okay, g'day students. We are looking at matrix multiplication today. So your skill that you want to be learning today, or your lesson goal, is that you want to be able to perform matrix multiplication now manually up to a 3 by 3. Where did that disappear to? But not limited to square matrices. So let's have a look at matrix multiplication. It's quite an interesting thing to do. So we're going to, when we think about matrix multiplication, we're going to multiply the rows by columns. So we'll look at first example is in this two matrices. We've got matrix A and matrix B. You can see that matrix A is what? A, B, C, and D. So top left is A, top right is B. Bottom left is C and bottom right is D, and E the corresponding ones. So A corresponds to E corresponds to A, F corresponds to B, G corresponds to C, and H corresponds to D. But when we look at matrix multiplication, we are performing a certain set of operations. We're going to multiply rows by columns. So the first entry in the top left will be row 1 times column 1. And the top right entry will be row 1 times column 2. The bottom left entry will be row 2 times column 1, and the bottom right entry will be row 2 times column 2. So if we were to think about this, the first set of entries would be AB times EG. Well, it goes like this. You go A times E, and then plus B times G, and that's your top left entry. So let's do the top right entry. Well, it's going to be the first row multiplied by the second column. So it's AF plus BH. Now going down the bottom, we've got the bottom row times the first column. So it's CD. Oh, what have I done? Yeah, CE, I've done that right. Plus D times G. And then finally, the second column and the second row get multiplied together. So we've got C times F plus D times H. And there we have our pattern. Now, I find it quite easier if we actually just move the matrices off to the side each other. So we put the second one just to the right and above and draw a table. And that way, this just says, well, everything in here, I suppose you can see what this is doing. We've set it up a bit like a table, and the same way. So this just tells me this stuff lines up with this stuff, and that's easier for me to think about it. And what's the next one? If I go AB and times FH, well, that's got to be there, and so on. So that's the way we multiply matrices. Now, it's important that the rows in the first matrix equals the number of columns in the second matrix. So, for example, if we had a second number of, or a third column here, well, what would happen? Well, we couldn't get a bunch of values over here because there's nothing existing over here. So that would not work. So let's have a look at our first example. So we'll let matrix A, so that looks like a vector matrix, and the next one's a square matrix. So what's that? 3 rows times 1 column, it's a 3 by 1, and B is a 2 by 2. So let this and this, A equal that and B equal that, and calculate 8 times B. Well, the point of this example is that you can't do it, because a matrix product cannot exist because the number of rows in the rows does not equal the number of columns in the second. Let's have a look at this one then. So, well, this has got to work. We've just got a 2 by 1, so we've got 2 rows, and this one's we've got 2 columns. You can see that they're different sizes, so we can determine the number of order, or the dimensions of the final matrix. So it's only gonna be a 2 by 1 in the end, and because it's only got 1 column here. So let's have a look. We need to multiply rows by column. So what are we saying? Well, 5 times 3. We've done that, and then plus, whoops, not that one, is it? Because we need to go rows. The first row is 5, then we're going to go by the column. So it's rows by columns. And then let's look at the second row, and it's 7 times 8 plus 7 times 6, and that's what we've got down here. Now we can just simplify those numbers. So 5 3 is 15, and 5 times -2 is -10. So 15 take 10. Well, that's got to be 5, and that's what we see here. And then 7 8 is 56, and 6 7s are 42. 50 and 40 is 90. 6 and 2 is 8, so that's going to be 98. Okay, now we're getting pretty tricky. So you can see that we've got what? We've got 3 rows and 2 columns, and we've got 2 rows and 3 columns. This is actually going to be quite a big and complicated one. We're going to actually get a 3 by 3 matrix out of this one when we multiply them together. So what we're doing, we can think of setting the each of these up there. So we're going to have to get a couple of values for each of these. So you can see that there's quite a few values there. So let's have a look at it. And I'm going to just work through this with the color schemes. So remember, rows times columns. So what have we got here? We've got the first row times the first column. So this one here, that's our first row, and that's our first column. And you can see that I've color coded them for your ease. So first row, here's our 0, 0, 0, multiplied by 5, plus second entry in the first row is 5, and we're multiplying that by -3. And you can see that we need to then move into the second row and the second column. Is that what we're doing? The first row and the second column. So let's do that. So we've got 0, that's our 0, and here's our rows by columns. So second column, there's our 3 there, and then what do we got? 5, 5, and -2, -2. And you can see the systematic way I'm approaching this. Then finally, we're going to have a look at what have we got? The first row this time. Now we're multiplying it by the third column. And here we go again. 5 and then times 6. And so we've got those entries there. And so that's our first row done on multiplying matrix A by matrix D. I would recommend pausing the video and studying this carefully so you get the pattern. Once you've got the pattern, we can simplify. And so we can just simplify what's 0 times 5 plus, well, that's 0. 5 times -3, well, that's -15. So you can see this, these calculations involving matrices at the moment are complex. There are a number of steps, but they are not challenging in terms of difficult multiplications at the moment. So we want you just to understand the concept at the moment of the pattern on how to multiply matrices. Okay, let's have a look at an identity matrix. Remember, an identity matrix has the leading diagonal with 1s. That's naughty boy there, Mr. Beasley. I need to fix that one up. So if I want to look at the identity matrix for matrix E, you can see it's a 3 by 3 square matrix, so I'm going to need an identity matrix, which is an I3 matrix. So what do we got here? We've got the same, we've got identity matrix of E. So what we're going to do, we're just going to multiply rows by columns. So let's do that. So what we end up is with, let's have a look. The first row multiplied by the first column. Well, that times that is 0, isn't it? So we're just going to be ending up with 3 times 1. And does that make sense? I hope it does. i.e. 3 times 1 and 5 times 1, first row, first column, etc. And so the identity of E with the identity matrix is the same as what we put in. So the point of an identity matrix is that, remember, any number multiplied by 1 is that number. So that number keeps its identity. So we can also just consider using this layout. This is not in your textbook. I find this a whole lot easier when developing how to set out matrices. So finally, I want you to be able to check that you can perform matrix multiplication. We're breaking this exercise up, these mastery questions up, into 2 parts today. I just want you to do questions 1 to 7. They are simple routine apparently. So get a go at them. Make sure you can understand those steps in matrix multiplication.